This video is about roots being expressed as exponents that are fractions or rational exponents. Um, a lot of the stuff we talk about here is preparation for you to go to math10 or math10. If you know you're not going to go to math10 and math10 and you are confused by this, then you may use the calculator, but bear with me through my explanation because I think that the concepts are just as important as being able to do problems without the calculator. First of all, if you see problems like this with big numbers and fractional exponents, usually what this means is that they want you to do square roots or cube roots or nth roots, which is the exact opposite of multiplying a number by itself several times. Learning to do these is kind of like learning to do division of numbers. You have to be able to multiply numbers really well to be able to do division. And same thing with roots, with square roots, with cubic roots, and other roots. You have to kind of know what multiple multiplications lead to in order to know how to go backwards, okay? First step to doing that is to become familiar with the numbers that are squares or cubes or greater exponents for some of the smaller numbers, okay? So we're going to go through and write those down. So 2 squared is, 2 times 2 is obviously 2 squared, which is obviously 4. 3 2's multiplied together is 2 to the third, which you can see is 8 by multiplying the 4 times 2. And we can get each additional power of 2 by multiplying the previous power of 2 by 2. So we go 4, 8, 16, 32, 64, 128, 256, 512, and finally 1024, which I think if you know up to these, then you're in great shape, but oops. These numbers are also super important for people who are going to work with computers in their life because computers work with powers of 2. And one kind of coincidence, which is kind of famous among computer people, is that 2 to the 10th power is 1024, which is, you know, very close to 1,000, right? And I don't know if you've ever heard of when they talk about computer memory and they say, nowadays they talk about gig, but there was a time when they would talk about K, like 1K, 16K, 32K. When they talk about K for computers, they're actually talking about 1024 and not 1000 because it's actually a power of 2 that is close to a 10 base number, okay, base 10 number. So these are the famous powers of 2, and if you're going to do math seriously in your life, you should get to know these powers at least up to 1024. And another thing that these powers of 2 are useful for is if you know the powers of 2, then you also know the powers of 4, because as you can see, 4 times 4 is 16. That's a power of 2, right? That happens to be 2 to the 4th, right? And 4 times 4 times 4 is 64. That happens to be 2 to the 6th, which is the same thing as 8 times 8, right? Oh, wait a second. 8 times 8 is 64. That's the same thing as 2 to the 6th, right? 8 times 8 times 8, that is equal to 2 to the 9th, which is equal to 512. Okay. Now let's look at the 3's. 3 times 3 is 9. 3 times 3 times 3 is 3 times 9, which is, so it's 3 cubed, it's 27. 3 times 3 times 3 times 3 is equal to 3 to the 4th. It's the familiar 81 because that's also equal to 9 times 9, right? And then finally, 3 to the 5th power is equal to 243. And you don't have that memorized, but it's going to start looking familiar to you. 5 times 5 is 25. 5 times 5 times 5 is 125. And 5 to the 4th is equal to 625. Okay. 6 times 6 is 36. 6 times 6 times 6 is, 216. 7 times 7 is 49. And, these got mixed in here. 7 times 7 times 7, that would be 49 times 7, which is equal to 343. And finally, 9 times 9 is 81. Okay, so if you know all these, you're doing great. If you know some of these, that's okay. Okay, one thing that you can do is, if you have the calculator, is if you kind of remember what, if you look at 343 and you say, oh, I kind of remember that that might be a power of 7, then you can use the calculator to guess. You can guess kind of, oh, I think that was 7 squared, 49, 7 to the 3rd, 343. Or you could do the opposite. You could say 343 is the 1/3 power, or the 3rd root, and you get that it's 7. Okay, and then you went backwards. Now, the whole point of this is to be able to do some problems without the calculator for when you go to more advanced math. So that's why we don't resort to doing this every time. Now, 7 times 7 times 7 you could probably do on paper, but 343 to the 1/3 power, you're not going to be able to do that on paper, right? So like on paper you could say, oh, I'm going to do 49 times 7, and you can multiply that out and confirm that it is indeed 343. Okay, so that's the advantage of that. All right, so let's take this problem here, 81 to the 3/4, and we're going to figure out the answer to this without the calculator. Okay, so the way you're going to do this normally is you are not going, like when you see 81 to the 3/4, we know from our experience with exponents that this could be expressed either as 81 cubed to the 1/4 power, or it could be 81 to the 1/4 to the 3rd power. Okay, and we know that, I mean, if we did 81 cubed on paper, that would be, a ginormous number, right? So we probably don't want to do that. We probably want to do this. And you're like, we want to do the 4th root of 81? That does not look fun. Okay, but remember, if we express 81 as powers of 3, and we know that 81 is power of 3 because we know that 81 is 9 times 9. 9 times 9 is 3 times 3 times 3 times 3, right? So we could express this as 3 times 3 times 3 times 3 to the 1/4 power to the 3rd, right? And 3 times 3 times 3 times 3 is actually 3 to the 4th. So actually we have 3 to the 4th to the 1/4 to the 3rd. And 3 to the 4th to the 1/4 is just 3, right? Because 4 times 1/4 is 1, times 3 is 3. So actually the answer to this is 3 cubed. 3 cubed is 3 times 3 times 3, which is 9 times 3, which is 27. Okay, so see, this is possible to do problems like this without the calculator because they look scary, but if you look at it closely, you kind of know the cube roots and the square roots you need to do these problems. Okay, here's the next one, 49 to the 3/2. So in this case, 49 to the 3rd power would give you a ginormous number, so we want to avoid that. So we're going to do the 49 to the 1/2 and then take that to the 3rd power. You can see that like both of these are actually the same problem, right? Because you multiply 3 times a half, or 1/2 times 3, you get 3 halves, right? All right. So we don't want to do this one because we're going to get a ginormous number. We're going to do this one because actually we know that the square root of 49 is 7, right? 7 times 7 is 49. So actually that's equal to 7 cubed. 7 cubed is equal to 7 times 7 is 49. 49 times 7 is 343. Okay, and if you don't remember that, you can multiply that out, right? 49 times 7, 343, right? Okay, so do you see, if you know the square roots that I wrote above here, or the powers that I wrote here, then you can pretty much tackle any Math SL or HL problem that they're going to give you on the non-calculator portion of the exam. Okay, and if you are going to math studies, then you could just say, oh, 49 to the 3 halves, I know how to do that. I'm going to have my calculator all the time. And you just say 49 to the 1.5 or 3 halves, and you get 343. Okay, so here's one last problem here. And one thing that I think helps is if you write the base number as a multiplication of of prime numbers, okay? And this is a way of maybe avoiding all those, memorizing all those magic numbers that we just looked at, okay? So for example, 216, if you prefer to like factor it out with a factor tree, you say, oh, I know that one of the factors is 2, right? If I divide that by 2, I get 108. And then the two factors for 108 would be like 2 and 54. And then 54 would be 6 and 9, right? So 6 would be 2 and 3, and 9 would be 3 and 3. And we've just factored it all out, and we can see that 216 is actually equal to 2 times 2 times 2 times 3 times 3 times 3. And if we take that to the 2/3 power, we're going to rewrite 2 times 2 times 2 as 2 to the 3rd. We're going to write 3 times 3 times 3 as 3 to the 3rd. And then we're going to take all that to the 2/3 power. The 2/3 power is the same thing as if we took it first to the 1/3 power, and then we took the whole thing to the 2nd power. Because you see, if we have the 2/3 power, it's the same thing as 1/3 times 2, right? So now what we're going to do is we're going to say, okay, 2 to the 3rd times 3 to the 3rd is actually equal to 2 times 3 to the 3rd, right? Which is equal to 6 to the 3rd. Does that make sense? Because if you have 2 times 2 times 2 and 3 times 3 times 3, then it's the same thing as 2 times 3 times 2 times 3 times 2 times 3, which is equal to 6 times 6 times 6, which is 6 to the 3rd, right? We can also use power rules to do that. We know that if we have this, that this is equal to 2 times 3 to the 3rd, which is equal to 6 to the 3rd. Okay? So we have 6 to the 3rd to the 1/3 squared. Okay? And we know that if we multiply 3 times 1/3 the powers here, since they are a power to a power, then we can multiply them, and we get 6 to the 1st. And then we can multiply 6 to the 1st with 2, and then we get 6 squared. So our answer turns out to be 36. Okay? So that's another way that you could do it, by factoring. I'm not sure if that's easier or not, but it's a way that totally avoids any kind of memorization.